Okay, Assalamualaikum warahmatullahi wabarakatuh. And my name is Muhammad HAIKAL bin BAKHORUDDIN, and my number battery is SC1860. So today I want to present about ocean ion fertilization for subject planktology. So I will start about definition of ion fertilization. So what is ion fertilization? Ion fertilization is effective method to increase atmospheric carbon dioxide drawdown by adding iron to stimulate and boosting phytoplankton productivity in efficiency. So how did they know about the atmospheric gas composition in ancient time? For the first for the first point, confined air pockets in an Arctic and Antarctic ice core containing atmospheric carbon dioxide during the last glacial maximum. Contrast the carbon dioxide content of the atmosphere during the last glacial maximum to that of pre-industrial periods, which is pre-industrial periods is 280 parts per million, and for the last glacial maximum is 180 parts per million. So how did Martins come to this finding? Based on a Martin hypothesis, which is dust inputs are a primary natural ion source of ocean fertilization. And second one is increasing dust inputs is ion restriction during the last glacial maximum, resulting in a substantial rise in the biological pump in high nutrient and low chlorophyll regions. This is historic timeline where hypothesis was proposed. He later found out that the only way the iron was available in these areas are by winds of dust that blew over the ocean. In 1989, Martin sent out three lab technicians on a species cruise for a small-scale experiment to the Antarctic Ocean in order to test out of his theory that if adding iron to the seawater would increase phytoplankton growth, and the result proved his theory. Phytoplankton swarmed and crowded the iron-filled seawater and consumed all the nutrients available. Several months later, in 1990, he had his hypothesis probably sliced, and finally in 1993, scientists decided to test out his hypothesis. And now with some background on iron hypothesis, what is the objective on this experiment? First objective is induce a strong phytoplankton response to reduce atmospheric levels, and the second objective is increase marine carbon sequestration via the biological pump in limited, high nutrient low chlorophyll HNLC zones. So this slide is explained about areas of ion fertilization. Area chosen was focused on two high nutrient low chlorophyll areas where there were lower phytoplankton densities. By using satellite imagery, they were able to identify high nutrient low chlorophyll ocean located in subarctic North Pacific (SNP), equatorial Pacific (EPO), Southern Ocean (SO), subtropical North Atlantic (SNA). So this is examples of map overview for the areas of ion fertilization experiment. Why are these areas interested by scientists and industry? First of all, you have minimal chlorophyll and abundant nutrients (HNLC). The second point is iron deficiency prevents phytoplankton from fully utilizing the available micronutrients for photosynthesis. And the last, primary production is comparatively low in these HNLC areas despite the abundance of macronutrients, in particular nitrate and phosphate. So actually, iron and also climate change have a relationship where Martin proposed that high iron levels could be an effective way to stimulate oceanic carbon sequestration through a biological pump as iron as a stimulant, causing phytoplankton to bloom because phytoplankton consume so much carbon dioxide during the photosynthesis process and atmospheric carbon dioxide levels fall. The process of photosynthesis absorb dissolve inorganic carbon and nutrients. Upwelling process transport the nutrients. The effectiveness of organic material transfer is determined by the macronutrients uptake increase the absorption of dissolved inorganic carbon due to increased oxygen production. As a result, atmospheric carbon dioxide level will fall. So this slide is explained about ocean ion fertilization experiments from 1993 to 2009. There was a 6 natural ocean ion fertilization and 13 artificial ocean ion fertilization experiment. So there was a limitation in the ocean ion fertilization experiment. For the Equatorial Pacific, it has salvation of the fertilized patch, micronutrients or macronutrient limitation, insufficient experiment duration, and in subarctic North Pacific, you have single ion addition, insufficient experiment duration, and the Southern Ocean have insufficient experiment duration, light limitation, and high dilution rate by small batch. So, based on the overall result, all of the experiment, it failed to meet the expected outcome with the exception of effects result. The production of aggregates with rapid sinking rates, there is significant carbon export to deeper layers up to 3,000 meters below the surface. The majority of artificial ocean ion fertilization experiments have resulted in an increase in primary production while decreasing macronutrients and dissolved in organic carbon. Drill down, however, their effectiveness in increasing export production has not been demonstrated. Except for effects, everything is confirmed. Several issues arise as the result of introduction of iron into the study areas, such as lower biogeochemical response with no discernible change in the carbon flux were not detected during the experiment. So the next is improvement that can be made for the ocean ion fertilization experiment for the future, such as location, timing, duration, effective tracing, strategy, and monitoring of possible effect. So the improvement for the future is location, prioritize area contain a numbers of data, and for the duration, concentrating on how much time the phytoplankton bloom will require, and for the strategy, method for producing a phytoplankton bloom by increasing and maintaining the concentration of dissolved iron. And the time is ensuring that the experiment is carried out at the appropriate time. For the effective tracing is conduct more research on how natural blooms form in accordance with the chlorophyll patch that satellites can see. And for the last, monitoring of possible effect. After iron is added to ocean water, it must considering any negative consequences on the marine ecosystem. So that's all of my presentation. Thank you.